Hi, my name is Sachin. I've been working as an educator and technical consultant for the past 18 years and have been coding since the early 90s when I was introduced to a Sinclair Spectrum home computer. I'm really excited to present this course. In this course, we'll take a look at components in React. We'll begin by defining components and their purpose. Then, we'll learn about the different types of components that React offers and their key features. Finally, we'll get hands-on with code and build a small quiz app that demonstrates the use of React components. If you've never used React, then this course will get you started right away. Maintained by Facebook and a community of individual developers and companies, React is a JavaScript library that helps you build user interfaces. Facebook built React to solve efficiency and scalability. But that itself is quite an understatement for what React truly is. Let's see why. At the heart of React is the concept of declarative programming. Let's visualize declarative programming using the example of a checkout screen in an online shopping application. Here, you can see a list of items that the user has added with quantity and cost. And you can see the total amount at the bottom. If we separate the data from the visual elements that you see, then we'd get something like this. We simply have an array of products and the per unit cost and quantity purchased. This is the data that drives the interface. Changes to this data should update the interface and the calculations on the price. Now, let's say we want to add another product. This should be as simple as adding the product to the array on the left. This should automatically update the UI on the right. Pretty simple, right? Let's call this data layer as state. React uses the concept of state, which essentially describes the contents of the interface. Whenever the state is changed, the interface automatically updates to reflect the change. You declaratively update the interface by simply updating the underlying state. Everything else is managed seamlessly by React. This makes it really easy to imagine your application in terms of data and not in terms of technical nitty-gritties such as document object model or DOM manipulation, selectors, and other things that you would otherwise need to worry about when building a web application. But what really makes React apps super efficient and performant is the concept of a virtual DOM. Instead of manipulating the real DOM every time, React creates a virtual representation of the real DOM in memory. Now, every time your UI needs to update, the changes are first performed on the virtual DOM before reconciling it with the real DOM. This eliminates the need for expensive interactions with the real DOM every time that the UI needs to update. These are just some of the reasons why React is the weapon of choice for building enterprise-grade user interfaces and web applications. But an even bigger reason to pick React for your next killer product is components. Components are the building blocks of a React application. Simply put, components help you break down an interface into smaller manageable units. When you're on Facebook, there are so many features that you see and use, from individual posts, like and emotion buttons, the create post section, notifications section, and so many other elements. Imagine all those as one huge monolithic code base with a ton of nested and intertwined features. Not exactly appetizing, right? In fact, a pretty bad idea. But as individual components, not only can you isolate them as features, but develop them independently of other features, thereby bringing scalability to the equation. In fact, Facebook, as of February 2019, uses more than 50,000 components on Facebook, and they are all built using React. This is what makes React a battle-hardened solution that you can bank on easily. Now, components let you focus your energies on building great features. Add declarative rendering with state and the virtual DOM, and you've got yourselves the right toolkit for building great user interfaces and apps. Remember, everything that you build with React is a component. Let's visualize a user interface and how components can help us break it down into manageable units. Here's a social card that you would typically see on a social media platform like Facebook. This card contains the user's profile picture, an image, a headline, and 3 call to action buttons for liking the post, commenting, and sharing the post. We also have a comments box at the bottom. To begin with, the social card itself would be a component that brings data in from a source and display it on the UI. The social card component itself can be broken down into components. The profile component, for instance, is responsible for the profile picture and the name of the user. The post content component handles the text and image for the actual post. The CTA buttons house the like, comment, and share buttons, and the comment box lets users type comments. By breaking down the UI into functional components, not only does this bring logic and sense into the design process, but it also makes manageability a breeze. For instance, when a new CTA button is to be added, then only the CTA buttons component needs to be edited. If we look at the hierarchy of components, then you'd get something like this. The actual data comes through the top level social card component and gets passed down in a one-way data flow to all the child components. React's one-way or unidirectional data flow order simply means that a parent component will pass down data to nested child components using props, which act like inlets into a component. This unidirectional data flow order makes it easy to understand, implement, and debug common problems because we can easily recognize data sources and the flow. The bottom line here is that components are reusable features that you can compose together to create a user interface. By modularizing features, your UI scales efficiently as your app grows. Moreover, modular code means debugging is exponentially easier than a monolithic code base. But what does a component look like? React offers 2 kinds of components and enough flexibility to play around to find that right blend of features to get your job done. The first type of component that we'll dive into are known as class components. Creating a class component involves subclassing the component class from the React library. Here, you can see a class component named toggle button. The first thing I want you to focus on here is the render method. Simply put, the render method describes what the component should look like when it renders on the page. And for this reason, it is absolutely essential when building a React component. Inside the render method, what looks like HTML at first is actually JSX, a syntax derivative of JavaScript allowing you to write HTML-like layouts with the added advantage of using JavaScript expressions directly. For this reason, JSX will feel a bit different when compared to HTML. For instance, notice the class name attribute. This is the same as the class attribute in HTML. But notice the value of class name expressed in a pair of curly braces. This is a JavaScript expression. The ternary expression here checks for the value of a state variable called isOn. And if it is true, it uses btn, btn_on class name or else just btn. This way we can dynamically render style effects that are based on the value of a state variable. And speaking of state variables, notice the state object with the isOn property set to false. Class components allow you to declare local state properties. These properties declaratively describe what renders in the component's render method. In our case, the isOn property dynamically sets the class name value. State properties such as isOn in our example are reactive in nature. Whenever the property changes, React initiates a process to recompute the render method, and the component renders again to display the changes. But how do we manipulate this state? In this example, we've built a function called toggle, which uses the setState method to toggle the value of the isOn variable. It is important to note here that state should never be mutated directly and must always be updated using the setState function. To run this function, we are using the onClick event listener, which is set to run a JavaScript expression, the toggle function in this case. OnClick is one of many event listeners that you can define in JSX. When a click event is intercepted on this div, React dispatches a synthetic event. React handles browser-specific native events seamlessly using the synthetic events mechanism. Now, notice this expression inside the render method. We are expressing the value of this.props.label. This is used to set the label text on our component. Props are read-only inlets into a component and allow you to pass data into a component from the parent. Using the toggle button component now is as easy as declaring it inside another component's render method, as you can see here. Notice the use of the label prop here, which has allowed us to set a text label on our button. As you saw in this example, a class component is the most fundamental form of component that you can build using React. A class component allows you to create and manage local state variables such as the isOn variable we used in our small example. We also saw the use of props for customizing the label on our button. There are additional features that class components allow, which we'll see in a bit. Next up, we have function components. Function components are simple functions that return a JSX template. At the top, you can see a function component named MessageBox, which simply accepts a prop called message to render the visual element as seen at the bottom. Function components are simple and lightweight components for when you need to render visual elements that depend mainly on props for their data. By default, function components do not implement local state and other features that you typically get with class components. While function components inherently do not implement local state management, the recently introduced Hooks API in React allows you to implement local state, and this somewhere blurs the line between class and function components. To understand this better, let's build a simple quiz application where we'll use both class and function components. But before that, let me show you the end result. Our quiz app, which I'd like to call QuizBee, offers you a set of 5 general knowledge questions when you open the page in your browser. For every question, as you can see, we have 4 option buttons and you have to pick one. As you go about choosing answers, only the chosen answer buttons stay on the UI while the rest are removed. And when you're done answering all the questions, you can see a score out of 5. You also get a button to play the quiz again, and when you click that button, you're again taken to the quiz screen, but this time you'll typically see a fresh batch of 5 questions to answer. The purpose of this web app is to demonstrate the use of components. The easiest way to use React on a web page is to simply use a script tag to bring the React library in from a CDN. But building React apps using modular code and components requires a little more than a script tag. We can use modern JavaScript toolchains using module bundlers like Webpack to easily build and produce efficient React apps that take full advantage of the latest JavaScript features. React offers the Create React App, a command line tool for quickly setting up an application scaffold for building modular React apps. So let's begin by using this utility first. Make sure you're using a recent version of Node.js. I'm using version 10.8.0 for this example. On the terminal, I'll begin by typing npx create react app followed by the name of the folder in lowercase. This folder will house our application scaffold and will be created by the utility. We are using the npx package runner to directly run the create React app utility from the npm registry without the need to actually install it locally. Once the process completes, you can see a set of folders that have been created by the utility. Among these, the src folder is where you can build your React components. For now, it carries a basic demo application. So, from inside the QuizBee folder, I'll run npm start to kickstart the development server. The development server allows you to interactively build your React app and see live updates in the browser without the need to refresh the page. This is also known as hot reloading. At this point, you should see this page in the browser. This is a demo app that comes along with the initial setup. Since we'll be building our app from scratch, I'll delete everything in the src folder. Our app needs to query an API to fetch questions and answers. To simplify this process, we've built an offline API for this example. We have also built a style sheet to go along with the components that you'll be building. Let's download these first. Here's a link to download an archive containing the style sheet and our simple quiz service. Go ahead, download and extract the archive first. I'm going to copy and paste the assets and quiz service folders in my src folder so that my application can access these easily. Let's build our root component first. Create a new file named index.js in the src folder. This is going to be the root of your application and the file which is used by the Webpack build system to traverse the hierarchy of components that we are going to build. Whenever you're building a React component, you need to import the React library first. Additionally, we are also importing the component class because we'll be building a class component in this file, which is subclassed from the component class. Next, let's import our style sheet like so. This may look a bit weird, but importing style sheets into a JavaScript file is a standard practice since our Webpack build system supports it and will automatically create the necessary files for distribution at the end. I'll now create my root component, a class named QuizBee that extends the component class. Inside here, I'll first create the render method, which will return a JSX template that will render on the page. For now, I'll simply create a div with the class name property set to container, inside of which I'll make another div with the class name set to title, and we'll key in the title of the app, QuizBee. Since this is JSX, attributes and properties will differ from standard HTML. The class name property here is the same as the class property in an HTML element. One of the finest things about React is the separation between the core library and the medium to which it renders the result. Consequently, the browser's DOM is not the only target that React supports. React can be used to create cross-platform mobile apps using the React Native project, where the target medium is either iOS or Android. Similarly, there is a renderer that allows you to create SVG files using React. Since we are building a web application, we'll need the React DOM library to render our application on a web page. Let's import the React DOM library like so. We can then invoke the render method from the React DOM library, passing in our QuizBee component as the first argument and a selector to an element in our HTML file to render the component into. If you're wondering where our HTML file is, it's inside the public folder, as you can see here. This file contains a div with the ID root, and this is where our QuizBee app will be mounted into. This file is created and managed by our build system, so you don't need to do anything about it. Alright, I had saved the file, which causes the React development server to hot reload the page. So at this point, you should be able to see this UI in your browser. This is our application frame. Congratulations, you've just built a React component. Our QuizBee component just renders an application frame at this time. What we want to do now is load a set of 5 questions and answers from our quiz service API. This should happen whenever the application is loaded in the browser. We need a way to execute an API call when our QuizB component loads for the first time. This can be done using a lifecycle method. Every component goes through a cycle of birth and death. Across this timeline, there are various key points where React allows you to run custom code. This lets you design custom behavior. This diagram depicts all lifecycle methods that occur between the birth of a component, known as mounting, to when a component is destroyed and removed from the DOM, a process known as unmounting. If you look closely, you'll notice a familiar method, the render method. When the render method runs in the mounting phase of a component, it creates the base DOM nodes for the elements described in the render method of the component and allows React to get hold of them if needed. Thereafter, the component did mount lifecycle method can be used to asynchronously bring in data from a resource such as an API. Once the data comes in, we store it in the component's state. This causes the updating phase of the component to run, and the component re-renders to display the changes. So let's use the component did mount method to bring in our set of questions and answers from our quiz service. The quiz service API that we have here simply contains a batch of 50 questions, each with 4 answers, 1 correct answer, and a unique ID. But what we are exporting out of this service is actually a function that randomly picks 5 questions and returns back to the caller. We're returning the result as a promise, as you can see here. Back in our index.js file, I'll first import in the quiz service module. Then I'll instantiate local state for this component with an array named question bank. This is where our 5 questions would be stored once we pull them in from the API. We are creating state variables in our root component here because state should always be located at the nearest parent. This lets you centrally store and use state data and makes it easy to debug and reason with data flow in the application. Also notice how we have declared the state. This isn't the usual syntax that one would see in a JavaScript class. We are using the public field declaration syntax, which is currently on track to feature in ECMAScript 2019 and is at stage 3 of the TC39 process for approval of features. The reason why we are able to use it already, along with other things like ES 2015 import statements, is because our build system here uses the Babel compiler. This allows you to use bleeding edge JavaScript features today when building your React apps. This way, your apps are future safe already. I'll now write a function called getQuestions, which simply invokes the quiz service API and proceeds to populate the question bank state variable with the results. Note the use of this.setState to update the state variable. This is the only way you should update a state variable. You should never write to a state variable directly. Once this function is done, we need a way to run this function when this component loads up. This is where our component did mount lifecycle method comes into the picture. So I'll create the component did mount function and we'll simply invoke this.getQuestions here like so. Now that we have the data to use, I'll go into the render template here and I'll use a pair of curly braces to render this data. First up, we'll simply check to see if our question bank array does have data to render. This will ensure an attempt to render the data only when it is available. I'll then use a map function where I'll use destructuring on the question objects and we'll return back a set of h4 tags with the question text for now. Save the file and your browser should now be able to display a set of 5 questions on the page. Try refreshing the page and you'll see a different set of questions every time. We use the component did mount lifecycle method to bring in a set of question objects from our API, and we populated a state variable with this data. We then rendered the question text from this data in our JSX template. It is important to note here that any changes made to the question bank array would automatically signal an update, causing the component to re-render with the updated data. For now, we have just rendered a set of H4 tags. Let's now build a component which will display our questions as well as a set of option buttons for the user to pick. I'll begin by creating a new folder in my SRC folder named Components. We'll store our components here. Inside this folder, I'll create a component called QuestionBox in a file named questionbox.js. This component will render the question text as well as a set of buttons to let the user pick an answer. As always, we'll begin by importing React. It is important to note that React must always be in the scope when creating components. This component is also the perfect opportunity to demonstrate function components. Unlike the QuizBee component, I won't create a class in this case. Instead, we'll simply create a regular JavaScript function named QuestionBox, which brings in props using a single argument. Instead of the argument, however, we'll destructure directly to extract the question and options. Then, we'll simply return a JSX template like so. For now, I'll render the question text like so. And let's not forget to export our function component. Now, in our root component file, we'll import the component first. And then instead of the H4 tags, we'll render instances of the QuestionBox component where we'll pass down two props, namely question, which will be dynamically bound to the question text, and options, which will carry an array of answers for us to render buttons. I'm also setting a property called key to the unique question ID that we get in our data. The key property is essential when rendering lists, as it helps React identify and correlate an instance of a component with the data that it consumes. Our app now displays QuestionBox component instances instead of the raw H4 tags. Pretty cool, isn't it? The QuestionBox component will ultimately look like this when it renders the answer buttons. Now, when a user presses one of these buttons, we want the rest of the buttons to be removed from the UI. This can be done by using a local state variable to hold the options array when the QuestionBox component is created. We can use this state variable to render a set of buttons. When the user picks an answer, we can simply replace this array with just the chosen answer, causing the option buttons to be removed from the UI. Now, function components, unlike class components, do not provide state management features. This is ideal because you won't want state management and lifecycle features in components that only have to display data and provide simple interaction features. Having said that, should you need to incorporate state in a function component, React offers you a plug-and-play API known as hooks. I'll begin by importing the useState method, which will allow me to incorporate state in a function component. I'll then create a state variable named answer using the useState function, and we'll set the initial value of the answer variable from the options array that we are getting here as a prop. The setAnswer here refers to a function that can be used to update the value of the answer variable. With this in place, I'll use the map function on the answer variable to render a series of buttons like so. I'm using the value of the index from the answer array as my key attribute, which is not ideal but works for our simple example. Ideally, you should use unique values which will never mutate. And here we have our options button on our UI. To intercept clicks on these buttons, we'll use the onClick event listener property, which will run a function. Inside this function, we'll run the setAnswer method that we declared using the useState hook, and we'll rewrite the answer state array with a new array containing only one element, the chosen answer. If we now click on the buttons, we are only left with the selected answer button, as you can see here. The use of the hooks API and the useState method is ideal for this example. You may, however, be tempted to ask, why didn't we use a class component instead? The answer to that is, yes, you could just use a class component instead. React offers you more than one way to create components. In this case, a class component with its lifecycle methods and state management is perhaps an overkill. A function component with just one state variable is perhaps a more efficient idea. However, feel free to implement the question box component as a class component. We also want to compute our user's response and maintain a score. This can be done in the QuizBee component, but we'll need to pass the user's response from the question box component to the QuizBee component. This can be done using props. So let's add a new prop called selected, which will be a function. And we can simply run this function when the user presses a button, and we'll pass in the chosen answer. Back in the QuizBee component, the selected prop will run a function called compute answer, which will get the user's response and access to the actual correct answer which we are getting from our API. The compute answer function will check to see if the user's response matches with the actual correct answer, and if so, we would want to increment a score count. So let's add two state variables, score to keep the score and responses to keep a track of the number of questions answered. If our user answers the question correctly, we'll increment our score by 1. But in all cases, we will increment the responses by 1 so we can track the number of responses. We are using a ternary operator here to ensure we don't overset the value of responses beyond 5 because we have 5 questions. This way, I can add another condition for rendering the question box component. If the value touches 5, we know we want to display the results. Now, once we have registered answers to all our questions, the question box component does not display anymore. This gives us the opportunity to conditionally render the result. So for now, we'll simply render an h2 tag with the score. And it works as expected. Now that we are using state to manage our score and the number of responses, we can build another component to display the results and also offer the user an option to play the game again. Begin by creating a new file named result.js in the component folder. We'll first import React as always. Then we'll create a function component called result. As props, we'll bring in the score and a prop named play again, which will be a function that will allow the user to play the quiz again. We'll create a div with the class name scorecard. We'll create another div to output the score like so. We'll also build a button where we'll simply invoke the contents of the play again prop as a function. That's it. We'll export this function now. Back in the QuizBee component, we'll first import in the result component, and then instead of the h2 element, we'll render an instance of the result component. We'll also pass in the score and a reference to a function called play again, which we'll build now. The play again function will do two things. First up, we'll invoke this.getQuestions to fetch a new set of questions. Second, we'll reset our score and responses variables to 0. This will bring up the question box component once again because we are conditionally rendering it based on the value of the responses variable. And our QuizBee app is now complete. Let's play with it. I'll randomly choose answers and I get my results screen as expected. I'll click on the play again button now and I'll get a fresh set of questions to play. With our QuizBee app complete, there's just one more thing to do. So far, we've been using our development server to build our app. But this is not what you're going to upload on the server. We need to create a production build for our app. This process creates compacted bundles so you have a minimum set of optimized files to deploy. Small and less number of files means less number of HTTP requests when users access and use your app. Developers benefit from writing modular code spread across several files, folders, and assets. The production build brings this down to just a handful of files that are optimal for deployment. So let's create a production build. First up, I'm going to terminate my development server by pressing Ctrl+C. Then we'll execute npm run build. This will take a couple of seconds depending on how big your app is, and at the end, you'll get your final build ready to deploy in the build folder. As you can see here, our build folder contains a JS folder which contains our code along with the React DOM libraries and other code, all compacted, a CSS folder with our style sheet, and we have our index.html file in the root along with a few other assets. To deploy your app, just upload everything inside the build folder to your server, and your app is ready for use. So there you have it. We built a simple quiz app in a short time. I'm sure you enjoyed building this project with me. React is a lot of fun, and the more you explore it, the more you're going to appreciate the library and the value that it brings to your development workflow. React components help you break down even the most complicated UIs into simple and manageable units. We examined the kinds of components that React allows you to build and their key features, including state variables, lifecycle methods, and the hooks API. We also saw how props, which enable us to implement one-way data flow, can be used to bring in data into a component and as a conduit for running functions to pass data up to a parent component. So go ahead and build your next UI with React components. Thank you for watching.